As I mentioned earlier, my first experience testing beams and bending was actually working with Rice Krispie treats with 5th graders. And one thing that I didn't think about when we were hanging the pea gravel from my Super Rice Krispies was where the girls' feet would be. And it turned out that they wanted to be right under where all that pea gravel was going to fall. So as we designed these crash test approaches, safety was my first priority. We also wanted to make sure that we could accommodate a range of beam strengths, because these folded cardstock beams from Lab 1 are quite fragile. So for Lab 1, we've devised a simple pendulum drop test. Whoops. And you can vary the mass of the water in the bottle, and you can vary the height from which you drop it. So you can create a fixed energy crash test condition, or you can determine by increasing energies whose beam performs the best. The students can also film the deflection if they have a high-speed camera in their cell phone. So we've included a Quadrille piece of paper inside an old cardboard box as a way to provide you a measuring device. And we figured that most everybody has a ring stand somewhere in their school. So we simply snug the beam up against the ring stand support. I have duct tape wrapped bricks behind here to make sure that nothing moves. From a safety point of view, you just want to make sure that nobody's in the path of the bottle. So we're going to adjust this. I've got an aim line written on my beam, and I want to try to hit that pretty much dead center. So we can determine what our crash test criteria are. We could say we're going to drop from a fixed distance above the table, or just come to 90 degrees. I'm going to start out a little bit lower because I'm not sure how strong this particular beam is going to be. So I want to try to square him up and let her rip. Well, that didn't do much damage. Okay, so we definitely had a crash event. We can look at the permanent deflection on the beam, and we can relate that fairly easily back to the IIHS crash test. Okay, so crash test method number 2 is devised by Scott Spoler, who teaches down in Ohio. And Scott is a shop teacher, an industrial technology teacher, so he drilled holes in a PVC pipe. You could also put holes in a heavy cardboard tube, like from gift wrap. We have a pin that goes through the holes. We can vary the energy of our impact event by varying the height from which we drop a mass. And we can also vary the mass. I have 3 different masses here. These are just 1-inch bar stock of steel, cut so that they fit down the inside of my tube. We would normally attach the tube to something in the classroom so the weight of the tube is not resting on our sample. But for our demonstration purposes, we're going to start with a big mass. This is 238 grams. We have our pin at the 4th height position here, and you physics teachers will know how to convert this from potential to kinetic energy. Fire in the hole, pull the pin. Okay, so we have failed a crash test with our beam, because obviously that didn't protect the people inside. So we can back off on the mass and run it on the other half of this beam. And you can see how simple this is. Sorry, it's a stretch to get that up there. Okay, ready, set, go. Okay, so we've dented our beam, but we haven't broken it. So this is a real versatile piece of equipment. You can use it to break concrete samples as well. So that's crash test idea number 2. I like it because you can see if the beam had bent but not broken. You can get a measurement underneath. And it's also very difficult to get a body part underneath the crash zone. So this is crash test idea number 3 using household ladder, string, and 2 pieces of broken paver blocks scrounged from Home Depot for free and wrapped in duct tape so they don't hurt the floor. This has actually been proposed as a good bounding exercise for elementary school kids. If you have to guess how much energy it's going to take to break your beam, you could try bouncing different balls off of your beam to get an idea of what kind of mass is required. We set this up with our lasagna noodle, and this is a golf ball in a Ziploc bag wrapped with twine, so it's not a very elegant experiment. So for a fixed energy crash condition, you can set a fixed mass and drop it from a fixed height simply by laying a meter stick across your steps of your ladder and then lining the weight up with that meter stick so you know the height. Or you can vary the energy and determine the winner based on which beam absorbs the most energy without actually touching the floor at the end of the crash test event, because we're going to define touching the floor as a failure. Laura, you want to let her rip?
I'm ready. In 3, 2, 1.
Okay, so our golf ball from that height cracked our lasagna noodle, but I had reinforced the bottom with duct tape. So even though the lasagna cracked, it didn't touch the floor. So our lasagna noodle with duct tape would have been a winner based on the test criteria that we defined. We can run this again with one of the foam beams and a larger mass to demonstrate how it works with this more substantial specimen. So we've just tied some zip ties around a hand weight and we're hanging it from the ladder. I've got one of our pink foam insulation beams supported between our paver blocks. And we're going to try to do this with variable crash energy by raising the weight to successively higher starting points. Laura, you want to let it go with the first one?
Here we go.
Oh, so that was too high. We need less weight. But that was a rather spectacular failure. We managed to break it in 3 places. Okay, so we'll try from a lower height and reduce the energy. All right, let's see if it can take a lower intensity hit. Okay, so you can see, physics teachers, how you can vary the energy very simply with this. Okay, so you might remember in lab number 4, the students are able to design their own beams by carving out supporting material where they think it's not worth the mass in terms of contributing to the stiffness, and they can add reinforcements. Here we've used bamboo skewers as our reinforcements, as though they were rebar. So we're going to see how much this beam can take. And this is our lower strength styrofoam, the white styrofoam insulation. Okay, Laura, let her rip. Let's see what we got. All right, we'll have to try again. Raise it up. Okay, this is one tough assembly. Ready? Okay, unscathed. 3 drops from as high as we can go. So I think, Laura, when you ran this lab with your students, you were having trouble getting things to break because they'd done such an amazing job reinforcing them.
We were, but they did start to lose track of the light weighting issue. So you do want to remind students that they do need to keep in mind the mass of their beam overall.